you're standing at the edge of a slow-moving river, which is 1 mile wide, and wish to return to your campground on the opposite side of the river, you can swim at 2 miles per hour and walk at 3 miles per hour. You must first swim across the river to any point on the opposite bank. From there, walk to the campground, which is 1 mile from the point, directly across the river from where you start to swim. Which route will take the least amount of time? So first off, we'll visualize the idea of what we're trying to do. Is you're at point A, 1 mile across from you is point B, and then 1 mile from B is point C. So what we want to do is swim to some point D, and then walk from D to C to our campground. When we're walking, we can do that at 3 miles per hour, and when we're swimming, we can do that at 2 miles per hour. So what the plan is that we're going to swim to some unknown point D and then walk to C the rest of the way. So we know that speed equals distance over time, so therefore time is going to be distance over speed. The total time that it's going to take us to do this is the distance from A to D divided by our speed, which when we're swimming is 2, plus the distance from D to C divided by our walking distance, which is 3.
Next, we want to find out the distances for A to D and D to C. Now we use the set of equations we have listed out here. AB squared plus BD squared equals AD squared. A to B is 1 from the picture that we have right here, 1. And B to D we labeled as X. So 1 squared plus X squared equals AD squared. That means AD equals the square root of X squared plus 1. Then we find the distance from D to C, which obviously would be 1 minus X to complete the 1 mile distance between B and C. Then we use total time equal to time 1 for AD over the 2 miles per hour swimming speed plus T2, which is equal to the distance DC over the 3 miles per hour walking speed, equal our total time.
Go. So we can set t as a function, and that function is going to look like the square root of x squared plus 1 over 2 plus 1 minus x over 3. And what we can do is take the derivative of that function, and we will get the derivative equal to x divided by 2 times square root of x squared plus 1 minus 1/3. From there, we can set the derivative equal to x equal to 0, and then solve for x. When we do that, eventually, we're going to get that x equals the square root of 4/5. In the term of that problem, that means that this distance right here from B to D is the square root of 4/5, and from D to C will be 1 minus the square root of 4/5. So now that we know the x, we can plug that back into our equation, the t equation, and we can solve that down to the total time it's going to take to swim from A to D, then walk from D to C, is about 0.7060 hours.